Okay, and our last one, number 5, says, what is the smallest perimeter possible for a rectangle whose area is 12 inches squared, and what are its dimensions? So they want to know the smallest perimeter, and they want to know the dimensions of it. Okay, so we have a rectangle. Easy picture for this one. They want the area to be 12, so in here they want that to be 12. Our sides we can call x and y. Okay, so smallest perimeter, that means our primary equation is going to be for perimeter, which means we have 2x sides, so this one, top and bottom, plus 2y sides, side and side. So our secondary equation is going to be the area. Area is base times height. In this case, base and height, we named them x and y. You can name them base and height if you want. That's totally fine. The area that we want it to be is 12. Okay, so from here, we want to choose one. It doesn't matter. You can solve for x. You can solve for y. We've been solving for y, so that's probably what I'll continue to do. So to solve for y, I'd have to divide both sides by x. So I'd get y equals 12 over x. So then I would take that and put it in here. So my perimeter would become 2x would stay plus 2. Instead of y, I'm going to put 12 over x. So that means my perimeter is 2x plus 24 over x. I can't combine those. Those need to stay separate. I want the smallest perimeter, which means I'm going to minimize. So in my calculator, I'm going to use the F3 function. That's my calculus settings. And then to minimize, I want it's the 6th option, so you can scroll down or you can just type a number 6 for F minimum, the function's minimum. So on our screen, what we're going to type is F min will already be there. And then we'll have 2 times x plus 24 divided by x. If you're worried, you can put that 24, since it's 2 numbers, in parentheses so that the 2 and it's 24 divided by x. Before we close the big parentheses, we do need to say derivative of x. So comma x, take the derivative of x, and then we can close the parentheses. A vertical bar, we have measurements. Measurements need to be positive numbers, so we need greater than 0. No negatives, no zeros. We need dimensions, and we need them not to be negative because we don't measure in negative numbers. So when you hit enter, you're going to get 2 times the square root of 3. If you put that in and get your decimal, so green diamond and enter, you're going to get 3.4641. We can take either one of those and plug it into our y function to get our other dimension. So that would be y equals 12 over 2 times the square root of 3. If you press your green diamond and enter on this, make sure that you put the 2 in the square root of 3 on the bottom, both dividing 12. You're going to get 3.4641. Look at that, they're the same. So, oh, that means we're a square. Wow. Okay, so those are my dimensions. But they said, what is the smallest perimeter? So I need 2. So what can we say? The smallest perimeter Well, we would take these two numbers and we would put them back up in our perimeter equation. Okay, so when we do that, and we do 2 times, so smallest perimeter would be, I'll do scratch work here, 2 times 3.4641 plus 2 times 3.4641 is our perimeter. So that would be 13.8564. We only need 3 decimals, so we can just write 3 decimals is 13.856. We did get measurements, so that's going to be inches. Perimeter is in inches. Made by the dimensions 3.464 inches by 3.464 inches. Or you can say made by a height of 3.464 and a width of 3.464. There are tons of ways to word this sentence. So if you worded it differently, that's not a big deal. But those are your final answers, and those are the numbers that you want to get to answer this question.